Today we're going to study Chapter 1, Section 3. Complex number system and solving quadratic equation in complex number system. Last section we studied how to solve quadratic equation, right? And the time when we solving quadratic equation and evaluate discriminant, we say when the discriminant greater than 0, we have two unequal real number solution, right? When discriminant equals 0, we have two equal real number solution. But when discriminant less than 0, and then that time we say there's no real number solution, right? Remember, I emphasize don't say no solution, but quadratic equation does have solution, just not real numbers. So today we're going to, look at a case. What if quadratic equation discriminant less than 0, and then how we deal with it? So today we're going to learn the complex number system and learn how to adding, subtract, multiply, and divide complex numbers, and solving quadratic equation in complex number system. All the complex number system is built up, by a foundation, and this foundation is this definition, how we define the imaginary unit. We know in real number world, any real number, raised to the second power is always a positive number, right? But what if we want to, study something when squaring it is not positive, It doesn't really exist, but we just imagine that was true, And then that's why we define something. Square equals negative number. So we call this imaginary unit. We denote by little I, and we define I squared equals negative 1. So you just have to memorize it, We define I squared equals negative 1. Again, in real number, we don't have such thing exist. Any real number square must be a positive number. Only in the complex number system, we imagine or we define I squared equals negative 1. So keep that in mind. So what is a complex number? After we have definition I squared equals negative 1, and then we can base on that to define our complex number system. So complex numbers are the numbers in the form of this, a plus bi, a plus bi. That's a complex number. So what is a, what is a b? A and b, they are real numbers. And a, we call it real part of complex number a plus bi. And the real number b, we call imaginary unit of complex number a plus bi. And the I is the imaginary unit. Remember, we define I squared equals negative 1. That's all the definition. We just define those. A plus bi is a complex number. A is real part, b is imaginary part, I is imaginary unit. All right, since we already define what is a complex number, let's see how can we do the mathematical operation. Just like a real number, we would like to add, subtract, multiply, and divide complex numbers. So in order to do those mathematical operations on complex number, first we have to have another definition, what is called the equality of complex number. So if we say two complex numbers, they're equal, So if we say z1, normally we use z to represent complex number. So if we say one of the complex number is a plus bi, one of the complex number, I use c1 to represent. And second complex number, I use c plus di to represent. So if we say z1 equals z2. Okay, so how we define the complex number? Two complex numbers, they're equal. If and only if the two complex numbers real part are equal. So A must equal C. And at the same time, the imaginary part, okay, and B must equals D. So only the two complex number, both real part and imaginary part, they're equal. And then we can say two complex number, they are equal. All right? You think about that for a second, see whether that makes sense to you. Two complex number, if we say they're equal, must satisfy two conditions. Real part must equal and imaginary part must equal. All right, and then how we add two complex number. So again, A plus BI, this is a one complex number. C plus DI, that's the second complex number. We want these two complex number add together. So how can we do that? The principle is real part combine. Okay, two complex number, real part can combine. They are like terms. Okay, and imaginary part combine. So pretty much it's like real number system combine like terms. Okay, so in this case, if you just consider I as any variable, okay, you just assume that it. So BI, B is the coefficient, right? And then DI, D is another coefficient of the variable term. So they are like term. That's why only like term can combine. You A and B, you cannot combine because next B have a little I. This is different term as constant. Remember, this is a real part, right? This is a real part, this is the imaginary part. So they are not like terms. You cannot combine real part and the imaginary part together. But two real part can combine, and the two imaginary part can combine. All right? That's how we add two complex numbers. And the same idea, two complex number do subtraction is real part subtract, okay, and the imaginary part do subtract. So here you need to be very careful, okay, because first complex number subtract second complex number. If you write it out, C plus DI for the second complex number, this as a unit, so you have to put parentheses automatically around the second complex number. Otherwise, you will have this sign issue, okay? Because now in front of parentheses is a minus sign. In other words, if you eliminate this parentheses, -1 need to distribute in. Okay, so if I write it out, A plus BI minus C plus DI, that's eliminated parentheses, that's the same as A plus BI minus C minus DI, right? That's why we got the real part is A minus C, and the imaginary part is B minus D, followed by the I. Okay, that's where this is coming from. It's B minus D, not a plus. Okay, the sign, be careful. All right, now let's look at some example. The first one, we want to do 3 plus 5i, and then plus -2 plus 3i. I will suggest you to do the addition subtraction in the vertical way, so you automatically line up the real part with imaginary part, okay, so you won't mess them up. Okay, this is a real part, right? This is the imaginary part. So if you line them up, you won't, mess up with them. So real part combine 3 plus -2, that's +1, and then 5 plus 3, that's 8. So we got a 1 plus AI. Okay, that's the answer. So the book show you the horizontal way, I show you the vertical way. You kind of, do your own, see which one, is more easy for you to understand, so you won't make calculation mistakes. All right? So let me do the B for you. 6 plus 4i, okay, minus, right, minus parentheses 3 plus 6i. Be careful, here is a minus, this whole thing in the parentheses. So in other words, if I change this sign to plus sign, both sign I need to change to a minus, right? That's a sign change. And then combine, right? This is the real part, this is the imaginary part, all right? So 6 plus negative 3, that's 3. And then 4 minus 6, that's negative 2i. Don't forget the I. So the answer is 3 minus 2i. I hope the vertical adding, subtracting form little help you. If you don't feel this way helps, and then you can just do the horizontal way. All right. Next, let's look at how to multiply into complex number. Multiply into complex number. Okay, complex number just like a real number world binomial, right? It's just like real number two binomial multiply, if you consider I as a variable term. So we apply the same rule called a FOIL, right? We do first, outer, inner, and the last, right? So first term is, let me just rewrite. First term, 5 times 2. I just write it out for you, okay? 5 times 2. This is the first term, which is 10. This is the first. Outer term, that's 5 times 7i. Okay, 5 times 7, that's 35i, right? That's outer. And then inner, that's plus 3i times 2, right? That's inner. 3i times 2, 2 times 3, that's 6, that's plus 6i. And then last. The last term is 3i times 7i, right? 3 times 7, that's 21. And then I times I, that's I squared. Is that right? And then remember, by definition, I squared equals -1, right? So actually, we simplify as 10 plus 35i plus 6i, and then 21 times 91, right? It's a minus 21. Okay, so any quadratic term of the imaginary unit I, you have to simplify it by applying the definition I squared equals 91. Okay, so this term actually constant term, but change the sign. Okay, if original positive, now change to the negative. So now we have a real part combined. 10 minus 21, that's real part. And then 35 plus 6, that's imaginary part, followed by I. And then final simplify. 10 minus 21, that's negative 11. And then 35 plus 6, that's 41i. Okay, that's how we got the answer, which is the same as book. Book did pretty much the same way, but it just used a 5 multiply the second complex number, and then use the 3i multiply second complex number. Result is the same, but what I did just use the FOIL rule, since everybody kind of familiar with the FOIL rule. Okay, but still up to you. Which way make more sense to you, you just follow, okay? So the product of complex number, actually the book put as a theorem. You can just memorize this formula, and then, you don't have to do the FOIL anymore. But personally, if I would do this kind of problem, I cannot memorize this complex formula. So that's why I'm still going to do the FOIL, because that's not, that much difficult, right? To me, remember this formula is more difficult, so that I would still do the FOIL. But again, if you have a good memory, you're, very confident, you can memorize this formula easily without any mistakes, and then you can just apply this theorem directly. Okay, it's totally up to you. But I would just do the FOIL.